Right, so in this video I'm going to have a look at the Junior Cert Higher Level Maths Paper 2 for 2017, and I'm just going to have a look at question 9. Question 9 here starts by looking at these three words here: corollary, proof and axiom. Write each of these terms in the table below to match each term to its description. So if we take a statement that is accepted without proof, well, that's just an axiom. A statement that follows easily from a previous statement, that's called a corollary. And an argument showing that a statement must be true, that's called a proof. So these are just definitions that you'll need to know. Okay, so part B then. Salem writes the following statement: if a shape is a square, then it must have 4 right angles. So if a shape is a square, then it must have 4 right angles. Now a square will also have 4 equal sides as well, but complete the converse of Salem's statement. So the converse is just the reverse, if you like. So they started off here for you. It says if a shape has 4 right angles, then it must be a square. So that's just the statement, or the converse rather. This is the statement here. This is the converse of that statement. Now here we're asked, is the converse of Salem's statement true or false? Well, it's false. And the reason is we can have a shape like a rectangle. So we have 4 right angles in a rectangle, but that's not a square. So you can just say a rectangle has 4 right angles, but is not a square. So we have a statement and then we have its converse. So statements and converses don't have to be, or the converse of a statement doesn't have to be true. So that's it really. So the answer is false, and the reason is we've just given what's called a counter example here. A rectangle has 4 right angles but is not a square. Okay, so the next one then is to do with a theorem that you need to be able to prove. So this theorem here is to do with a parallelogram, and we've got to prove that in a parallelogram opposite sides are equal in length. Opposite sides are equal in length. So a diagram then, we can just, you need to use a ruler, just draw a parallelogram. And we can call it A, B, C, D. I'll just use a large D here, and we're going to say that this side is parallel to this side is parallel to this side here, and we've got to prove that the opposite sides are actually equal. So what are we given? We're given a parallelogram. A, B, C, D, and we can also say that AD is parallel to BC. We can say that AB is parallel to DC. So what have we got to prove? We've just got to prove that opposite sides are equal in length. So we don't have to worry about angles, but just opposite sides. So we've got to prove that AD, the size of AD is equal to the size of BC. And we've also got to prove that AB is equal to DC. So these two sides here are equal in length. Okay, construction then, we can say construct the diagonal. Let's go from B to D. Or join B to D with a straight line. So what we're going to do is put in a diagonal here. Okay, now proof then. So the way I'm going to do this is we're going to prove that this triangle here, ADB, is congruent to this triangle here, DCB. If they're congruent, in other words, if they're exactly the same size, angles and sides, then this side must be equal to this side and this side must be equal to this side here. So let's do that. Now the way I'm going to do that is say that you have this side here and this side here are parallel. This must be a transversal then, which means we have alternate angles here and here. We also have alternate angles here, and we have a common side as well. This red line is a common side. Therefore, using angle, side, angle, these two triangles are congruent. So therefore the sides are equal. So that's what I'm going to do. So I'm going to have to move back and forward a bit here, but I'm going to start off by saying that the angle ABD, so the angle, do this in black here, so the angle ABD is going to be equal to the angle, so this is ABD, that's going to be equal to the angle BDC. So that's going to be equal to the angle BDC. Why? Because they're alternate angles. So whenever you make a statement in a proof, you've got to put down the reason as well. Now, I'm also going to say that the side DB is equal to the side DB. So the size of the angle, we'll say BD, usually it goes in alphabetical order, is equal to BD. Why? Because it's a common side. And finally then I'm going to say that, so I've done this angle and this angle. So now I'm going to do this angle here and this angle here. So ADB, that's going to be equal to the size of the angle. So this angle here is going to be equal to this angle here because they're alternate. This angle here is DBC. So this is the angle DBC. Why? Because they're alternate. Okay, so by side, angle, side, we can say that triangles, I'm going to say these two triangles, ADB, triangle ADB is congruent to, use these three lines here, that means congruent to the triangle DBC. Therefore, we can say AD is equal to BC and AB is equal to DC. So this side is equal to this side and this side is equal to its opposite side. And that's all we were asked to prove here, that the opposite sides are equal in length in a parallelogram. And that is it for this question.